would like to thank the organizer for inviting me here. So today I'll be speaking about super wicked problems because I have earlier mentioned about wicked problems in social systems and how it relates with natural and complex social systems. So today I'll be discussing about an extension of wicked policy problem, which are related with super wicked problems, where we are trying to find the part dependencies, including the approaches from complex system dynamics and statistical mechanics. Right, so this is the global risk report. This states about that we are living at the edge, critical transition, a lot of pressure on our planet, geoeconomical issues, geopolitical confrontation are already there. And then we have earlier reported on this UN paper, and this was about underexplored dimension of uncertainty and risk in human development. So where we have brought of kind of concept from complex systems dynamics, feedback loops, nonlinearity, and uncertainty as well, where the approach was from VUCA framework. The VUCA framework is volatility, uncertainty, chaotic, and ambiguity. And that is related, actually that was a concept initiated by the US Department of Defense. Later on, complexity adopted this, and then further, it was utilized in many of the real-time situation. I hope everyone is familiar with this. I'll try to build the logic from here. Here we have a lattice where we have interaction between elements. These interactions can happen non-linearly, and we have positive feedback loops and negative feedback loops as well. So positive feedback loops can be represented by the jump from the lattice at ladder, and negative feedback loops can be from the node where we have snakes. So this is like initiating the critical transition, and then the feedback loop will take care of that, and the system will further move towards ecological flourishing or the collapse. And this is related with super wicked policy problems, where we have these type of negative feedback loops that backfires the situation. So path dependencies in terms of betweenness centrality and network centralities play a very crucial role. So here what you can see, it's a boreal forest in Canadian region. Later on, because of the extraction from tar sands for extracting petroleum from these sands, this is the later stages of that boreal forest, and further it against backfire, which is a negative feedback loop through biodiversity loss, habitat destruction, and then later on, this increased activity of this extraction, mineral extraction, lead to public health issues as well. So things are interrelated, as we can see. I mean, nowadays we are, if a butterfly flaps its wing at the Strait of Hormuz, we are feeling something in our kitchen as well. So these are the wicked problems that we have already discussed, and our aspect is physics of complex systems, which try to map interconnectedness and feedback loops, where we can have critical transition or ecological flourishing from different perspectives. So I'll skip these aspects. So super wicked problems are where the time is running out. We have very lesser time to respond. In wicked problems, we have time, but in super wicked problems, this situation is alarming. Second is no central authority, which is one of the feature of complex system. Second, whenever we try to solve the issue, we create another issue, that is uncertainty and ambiguity from complex adaptive systems approach. Right, so then we kind of linked it with deep uncertainty to apply in various situations where we can have complexity inspired solution. So here we have World Happiness Report data collected from Gallup survey report. Another is from University of Maryland Global Terrorism Database. We tried to check what are the most unhappiest country rather than happy countries. So when we see, most of the time these unhappy countries are common across the years. We kind of mapped it for several years, 16, 17, 18, and so on. These countries were common there. Then I linked it with time series analysis of global terrorism database, and then we can identify that the countries there at that cluster, you can see Iraq, Somalia, and Kenya, Afghanistan, Nigeria, Yemen, and Syria are all conflict affected zone. Here we have taken the help of random matrices where n, the number of countries that are involved, are more than the time epochs that we have considered, which is why it's a short time series through random matrices. Further, we have casted it through multidimensional scaling, where we have projected one cluster of conflict affected countries and another which is not badly affected by the conflict. Then further, so these countries here you can see COG, Peru, Great Britain. Great Britain is from historical data, but COG, Kenya, and so on. These are giving us additional dimension where we can see the resources through World Happiness Report. So here, wherever we see less happiness score, we see some sort of resources. For example, in South America, you can see lithium triangle. Then we have Congo, where we have cobalt, Indonesia, nickel, and lithium, nickel, cobalt are a very important component of our renewable energy resources for electrical vehicles, mobile phone, batteries, and so on. So lithium, nickel, cobalt plays a crucial role, but wherever you see, you will see Congo is affected by the conflict, a lot of resource of cobalt. Lithium, nickel, plus graphene as well in some other part of the world. And then it can again, the processing can again be weaponized in times of volatility, just like as of now we have witnessed in the Persian Gulf. Then, so this happiness report is evident, but indirectly it is reflecting the conflict, and further it is reflecting the resources that are related with those conflicts. Later on, we have constructed a network for a global picture of conflicts, where we have taken a lot of data from 1970 to 2060 onwards, and it was about 68,000 data points. Later on, it became 190 sources and 280 targets. And then we have used the algorithm proposed by Alessandro Vespianani, backbone filtering algorithm. So that red part is backbone filtering algorithm. These are the most prominent actors involved in this type of network, which is further extracted, and the actors are here. Further, I'll just discuss only the specific case of Colombia, where the governmental change leads to the crackdown on conflict actors. But later on, what happened? They started attacking on those actors as well. So that is why we have a very deep, intricate network. But then the Sotos and others have argued that they should propose some policies measure that relates with the welfare of the poor communities. And when poor communities get some sort of welfare from the government in terms of land, in terms of monetary help, then the population that was going to FARC, okay, so the population that was going and working for FARC started decreasing. And that's how this feedback loop triggered in opposite direction for ecological flourishing. Second case is for the El Salvador, where we were seeing continuous rise in terms of network dynamics, but later from 1990 onwards, we did not see any evolution in terms of that network, which is because of the Chapultepec Peace Accords in 1992. Then this is related with mangrove dynamics. We are extending this work for 2018, 2021, and 2024 because a construction plan for overbridge was proposed, and then mangroves are supposed to remove, and then it will further increase the stress on the soil, salinity will increase, the first layer of the population will get affected who are more vulnerable in terms of their socioeconomical status. Third aspect is we have extended this kind of work with Professor Joseph Wittmeyer, where we have proposed intergroup suppression and migration aspect to study innovation diffusion on a two-dimensional lattice. So here we can see, so the particle can move from one place to another, that is migration. It can take birth, that is, it can adopt any new idea, or it can switch off from that idea to a novel idea. So it can move in two dimension and migrate as well. So there is birth, mortality, and migration, plus competition within the population. So for this, we have considered the Balker-Pacala equation, where beta I is the birth rate, mortality rate, and this is the population. All right, so I'll just jump to the result. So here we can see a heterogeneous group of population where the adoption is widely there, And then later on, it becomes kind of saturated, but here in the another group, it gets flattened. Okay, so the thing is, the second population adopt more faster, but then it kind of bored from that practice and move to a new one. All right, so here I stop. Thank you for your attention. If there is any question, I would be happy to take that.
Thank you.